Hello. Hello. Hello.
Good morning, sir.
Morning, morning. Only very few said a WhatsApp to everybody. They should join. Sunday सोते नहीं रहना चाहिए. So today is important machine learning methods we are going to discuss. Please tell everybody to join. Okay?
Yes, sir.
Send a WhatsApp message and everybody send the WhatsApp message to everybody so that all the people join. So we'll wait for 10 minutes. So I'll start at 9:15 again. Okay?
Okay, sir.
So are you ready, playwright? Hello? Hello?
हाँ सर, 18 लोग तो हैं, स्टार्ट तो कर सकते हैं.
Okay. All right. Now, okay, earlier two blocks we studied the basics of artificial intelligence, and your subject, your paper is artificial intelligence and machine learning. So now this block 3 talks about machine learning because basics of artificial intelligence, predicate, FOPL, all these things you have learned, truth table you have seen and all that, and you know how the artificial intelligence is working. So now comes the machine learning method. In machine learning method, most of the statistical packages are being used for fitting the data. So you have the data and you have the machine doing this for you and then predicting it to take training data, have the model, and then use it for prediction purposes. So that's the type of this. For example, you want to talk about election, you can do machine learning. You want to talk about seeing a movie, you can see machine learning. You want to have production of some new thing come up, you want to decide about this, that's it. All machine learning is a very very important process. So that's where it's a the unit 9 talks about introduction to machine learning. So this is what you say after artificial intelligence was introduced in computing world, there was a need for machine that would automatically make things better. That's it. So the main goal of machine learning, even at the most basic level, is to be able to analyze and adapt data on its own and make decision based on the calculation. That is, you want machine to become the decision maker. So that's what. Now, how does it happen? Because machine learning is what we need to make devices that can make decision based on the data. So data is the basic thing. That's where big data also use machine learning, and data in general use machine learning person. So to get this level of intelligence, you need to put algorithm and data into machine in a way that lets it make decision. So you have to make the data as well as the way it is put in the machine so that machine can take a decision. So for example, now GPS, you GPS data is used for mapping. You want to go to some place, you use GPS. You want to see how the traffic is, you again see the GPS, all the things. So then an algorithm that works like water flow can be used. Now GPS की story आपको पता है कि this Darshan Pichai was not that time CEO of Google, but he was one of the team leader, and he and his wife were invited for a dinner at a friend's place. Now house was there, they knew where the house is, The wife could reach in time, whereas Darshan Pachale reached almost by 10 o'clock in the night by the time the dinner was already over. So then he came back to the office with his team. They said, why should this happen? We should have a process by which you should be able to always locate the place. That's where GPS came up. Okay, so this is what is the story of GPS. Okay, this is one of the simplest example which we can understand how machine learning can, because GPS, you are going in a car, you have to, because for example, I was going in a car to Jaipur and I wanted to see GNU because I was invited to give lecture to the faculty of GNU. Now, I thought GNU is Jawaharlal Nehru University's another branch, but it was Jaipur New University. So I reached there, but GPS helped. GPS helped me to go to the place, which was very uh, fine and all that. That's how I do it. So that is GPS. This. The accuracy of the data as a whole is a topic of debate, since decision based on the data might be accurate, but it is one of the issue whether or not they are acceptable within the limitation. डेटा अगर अच्छा नहीं होगा तो आपका रिजल्ट भी अच्छा नहीं होगा. सो डेटा ही अच्छा होना चाहिए. दैट्स व्हाट it's important. Simplest example would be if we instruct an auto driving car. It's a auto driver, it's a artificial intelligent auto driver car is there to reach a destination at a specific time. It should also work within the legal boundaries of the land, not to break traffic rules to achieve the desired results. The boundaries and restriction cannot be ignored as they are very important for any self-learning system. That's important for automatic car. So this is also machine learning. Data input is the soul of the business. Data input is most important. So machine learning is key to unlock new world where customer data, corporate data, demographic data, all type of data are there. So that type of this, so it's a important thing. Both artificial intelligence and statistics. So it's machine learning goes into most of the statistics which you have learned. That's where you will see a lot of statistics being talked about it. So uh, both artificial intelligence and statistics research group contribute to the development of machine learning process. That's the this. So then you can say Michi et al. Says that machine learning usually refers to automatic computing procedure based on logical or binary operation that learn how to do a task by looking at the series of the examples. Machine learning is used in a lot of ways today, but whether or not they are all ready is a debate. There is a lot of room for improvement. So anyway, it's improvement is always there, but it's a giving estimated thing. It's a approximate thing. It's given by the results, which help because GPS give you which side the supposing you are going from in Delhi from Merit, you want to go to Delhi University. Either you go by a Rajghat or you go by another road. Now you have to see which side is more traffic. That again, Google GPS will tell you. So that type of thing is there. After going through the unit, you will know all this, understand the basics of machine learning, identify various techniques of machine learning, reinforcement learning, and deep learning, and understand ensemble. Now, ensemble, when there are a large number of things, there are a number of models combined, and result is ensembled models. So that's what it is. So introduction to machine learning, so understanding data, describing the characteristics of data collection and location hidden connection. So that gives you the method of machine learning. So the more conventional form of statistical investigations are the origin of great deal of prevalent data mining and machine learning. You have learned data mining and data warehouse. Machine learning method is using that. Data scientists have a background in technology and also have expertise in areas such as statistics, data mining, machine learning. This allows them to collaborate effectively across the field. So that's what is it. The process of data mining refers to the extraction of this. So this is what is the diagram. This is a data mining, this is statistics, and this is machine learning. So this is the flow of how machine learning needs statistics and data mining both. So data mining is the mining of data, creating of the data, missing data creation, data processing, and all these things are there. Machine learning, on the other hand, is the core of data mining technique infrastructure. They use to extract information from the raw data that is stored in database. This information is then expressed in form that is understandable and can be applied to a range of situations. That's where these things are there. So this is the because of three machine learning, data mining, and statistics are intervened. We must grasp this relationship. So that's you must see what are the relationship. You should look into it. So you can see most learning algorithms use artificial statistical tests to build rules. So that's the primary functions are A, B, C, D. That is to gain an understanding of the cyber phenomenon that produced the data that is being investigated, to abstract the understanding of underlying phenomenon in the form of models, to predict the future value of phenomenon by using the model that was just uh, generated, and to identify anomalous behavior exhibited by the phenomenon that is being observed. So election process, all these things, what is that changing scenario with each individuals and all that. So that type of thing. And then you are talking of new product building up. You are trying to have now electronic vehicles, and then you want to have automatic cars. All these things are important, but that's again you have to have machine learning method to know how they can work, so that they without breaking the rules of the traffic rules and all these things. This is happening. uh, Now you want to go to various tourist place. As a tourist you want to go, how will you go, where will you go, how much money you should spend, and all these things are important. So that type of things are done carefully by machine learning method. So all the frameworks have emphasized decision tree process, in which classification is determined by a series of logical processes. That's what say inductive logical procedures and all that. That you can read it. To learn means to acquire knowledge, to gain knowledge, to gain experience with something, learn a new skill, to memorize something, to acquire something through its experience, example are practice of doing so. So these are the machine learning process there. So technique of machine learning, the machine learning uses various algorithm. So you can see various algorithm will be shown. Machine learning cycle. So there is a making a machine learning application is similar to making a machine learning algorithm work, which is iterative process. You have to take the data and get the result. You should know the output also. That this is the result, and then use the data, get the outputs, similar output which is there, then that becomes your model. So no, on new data you can use that model, and so on and so forth. ये देखिए मशीन लर्निंग साइकिल है. Access and load the data, pre-process the data, drive feature using the pre-processed data, train model using the feature derived in step 3, iterate to find the best model, integrate the best trained model into a production system and use it. So that's the use of, so that you have the data on based on some sample data, you are creating a model, and that you start using that model for productions. So that's what is there. So data identification, data preparation, selection of machine learning algorithm, training the algorithm to develop a model, evaluating the model, deploying the model, performing prediction, access the prediction. So then you can assess, is the prediction okay, is the prediction can it improve, and all that. That again, it has been shown very clearly, more complicated model you build up, you are not able to improve your product, the machine learning process. The simpler the model, better it is. That's what is the same scheme, because you can ensemble, you can have simple model, 3 4 model, and you can have get the ensemble of these results, so that that model 1, model 2, model 3, model 4 unka result ले ले. That is what the ensemble there, that we'll discuss. Okay. Data comes in all shapes and sizes, so there are many different kinds of data. with Structured hai, semi structured hai. Data sets from the real world can be messy, with missing values, maybe in different formats. You might use simple numerics data, so on and so forth. Preparing your data might require specialized knowledge and tools. You might need specified tools and knowledge, so that's important. It takes time to find the best model to fit the data. So finding the best model, again, this, that's where I said you have simpler models, uh, take less time, have 3 4 models, so that you can do the assemble this. Does it appear to be challenge? Try not to let this discourage you. Keep in mind that you can achieve it. So each machine learning workflow begins with, what kind of information do you have to work with? How do you want to learn something from it? And how, where this new data will come from? So that's so supervised learning and unsupervised learning we have talked about earlier also, which requires training a model with data whose input and output are already known. And unsupervised learning, data is uncover previously unknown patterns and all that. So that's the supervised machine learning, supervised learning, unsupervised learning. Supervised learning is a classification, sport vector, discrimination analysis, naive bayes, nearest neighbor regression, linear regression. uh, all these are decision tree neural network. So whereas unsupervised clustering, partitioning algorithm, etc., hierarchical, Gaussian mixture, and neural network, a hidden Markov model. So these are the different models, supervised and unsupervised. That's what is used for machine learning. So if you need a train a model to produce a forecast, such as the future value of a continuous variable like temperature or stock price or a classification, etc., then go with the supervised learning. If you want to look at your data and train a model to identify an appropriate way to represent it internally, then you go for unsupervised learning. So this is what the supervised learning and unsupervised learning is. So supervised learning technique बता दिया है इसने, classification technique, regression methods and all that. Is it possible to tag or categorize your data? The classification technique of, if your data can be divided into different groups or classes, working with the collection of data, binary or multi class classification, etc. This you can go through that. That's the type of thing which you can say. The amount of time spent in training, the amount of memory needed, the accuracy with which predictions are made, and all that, level transparency, all these are important. So this is what is the classification of the data. This is a machine learning algorithm. So this is a deep Boltzmann machine, deep belief network, and so on. You can read that all these things are given here. All this, and on the side here, uh, out this Bayesian algorithm we have done, classification of this and all these things, chi-square test and all these things. So all these are all which you have done in statistics. If you know, that's all k nearest neighbors. All these things are they are learning vectors and all these things. These are all type of machine learning algorithms are these given here. So this talks about all the various things. And earlier we talked about supervised and unsupervised. Now we are talking about decision tree, how the method models is built up, how the regularization is done, on all the things, so clustering and all the things. So this is what Bayesian clustering, decision tree. Okay, so dimension reduction, हमने Hadoop करा हुआ है. Neural network, you know what is neural network is there? You have billions of neuron on your body. So similarly, you want to create the neural network. इसके diagram दिखाता हूँ. इसमें है नहीं. इसमें नहीं है. But I'll show you the diagram of neural network maybe to next class. Uh, इसमें neural network in diagram. It's a. I'll show you the diagram. So reinforcement learning and algorithm, that's again ये देखिए ये आपको अनसुपरवाइज सुपरवाइज का सारा प्रोसेस अगेन बताया हुआ है. मशीन लर्निंग है, देन neural set, neural nets and deep learning. So neural net and deep learning is a process by which you can do a lot of, again there's the build up a model, but weighting function both up and down, you know input, you know output. So you should know in the data input output to build up the model. Then you use it on the simple data, on new data, so that you can have prediction process there. So this is the neural network, and that's the deep learning process and all that. So ये है environment, agent, there are this next state, reward क्या, reward penalty क्या है, action क्या है, all the things. So it's something like that. You are thinking of you need a glass of water. So you have to plan. You have to get up, get a glass, fill it with water, drink it, and then leave it. So similarly, you are getting the reward for standing up. If you don't stand, you will have a penalty that you will feel thirsty and all that. So these are the type of thing which is explained here. So this is action, state, reward, policy, and all these things are mentioned here. This is uh, RL algorithm, model free policy optimization, Q learning, model based. अरे क्या हो गया? Model is given. So Q learning, policy optimization, model free RL. RL is the large number of RL algorithms are there. So this is the RL policy and all that. So that from there, next agents, artificial intelligence has always agents. Agents are, the agent is the person who learns and makes a decision, but agent is for the, but machine is the agent, the environment is the agent, the agent's environment, the group of things and all that, location, state, and all these are agents and all that. So model free versus model based. The model is used to perform simulation of a dynamic process that take place in the environment. In other words, the model learns the transition probability T S1, S0, A naught. There's a parenthesis there from the present state S0 and action A to the new state and all these things. That you can see that here. Initial Q table, choose an action A, perform action, measure reward, update Q. At the end of this training, good Q table. So that's where you say all these things. So deep Q neural network, action reward on policy, off policies and all that. So डीप लर्निंग एल्गोरिथम जो इसमें बताया हुआ है, देखो ये डीप लर्निंग है, ये मशीन लर्निंग है, ये आर्टिफिशियल इंटेलिजेंस है. So this is one within the artificial intelligence superset, और इसके अंदर ही machine learning और deep learning आ जाता है, but it looks as if they are separated. No, it's a artificial intelligence is superset, whereas deep learning and machine learning becomes subset of it. This is a neural net. This is a biological neural versus artificial neural network. This is a neural network. This is input. This is a weighting function. This is output. So you have hidden surfaces and all that uh, weighting functions are there. All these things are there. That's a human brain. अगर आप आपके हाथ पे चोट लगी फटाफट ब्रेन पर पहुंच जाता है कि हाथ पे चोट लगी है, पाँव में चोट लगी फटाफट ब्रेन पर सेंसर पहुंच जाता है कि ब्रेन वहां चोट लगी है. Exactly same process has been considered in artificial neural network. So this is what I wanted to show you, that feed forward neural network. ये देखिए, ये hidden surfaces है, hidden layers are, these are the hidden layers. This is the input layers. This is output is one. So initially building up the model, you take the data for which you have both input and output known. So you have input, and from hidden layer you have weighting functions. So create, go backward and forward so that you get from input you get output, reasonably good output. So then that becomes your model, and then you can use on the new data, new input layers and all that. So this is the neural network. This is again saying convolutional neural network. तो उसमें हुआ ये देखिए कैसे वो सारा recognition based on convolutional neural network. Then recurrent neural network, RNN, is this. This is a recurrent neural network. Encoder, code, outcode, decoder. So therefore, an encoder and decoder are included as auto encoders. The encoder receives the input and encodes it into the lower dimension. So that's what it is. So this is coded and on this restricted Boltzmann machine. So this is again their generative adversary network. All these things are there. So then ensemble method. Ensemble method is where a general meta approach to machine learning that combines prediction from different models to improve prediction, so that you have model 1, model 2, model 3, and so on, so that on that you get the ensemble results of this. So this can create subject of ensemble learning is dominated by three methods: bagging, stacking, and boosting. Bagging ensemble learning is the process of fitting multiple decision trees to various samples of same data set and averaging the result. Stacking ensemble learning is fitting multiple uh, multiple types of models to the same data and then using another model to learn how to combine the prediction in the best way possible. Boosting ensemble learning entails successfully adding ensemble membrane that corrects prior model prediction and produces a weighted average of the prediction. So, so now let's do the bagging ensembles. The पढ़ लीजिए, all these things are there. Okay. ये है bagging ensemble के sample 1, sample 2, tree 1, tree 2, combine output is there. So these are the all samples. So सारे के combine करके यहाँ पर ensemble से result होता है. This is ragging ensemble learning, bagging ensemble. Then you can talk about the stacking ensemble learning, model 1, model 2, model 3, model को output लेके यहाँ से stacking ensemble learning. So this is the stacking. This was bagging उसमें different trees लेके. And then third was boosting. So input model 1, weighted sample 1, model 2, model 3, model 4, combine and then output. So this is the simplest way of ensemble forecast. So that boosting the result of this. So this covers up the unit 1. Any question on the unit 1? So we studied the machine learning process as a domain for using statistical and deep learning and neural net, all the things we have used, so that we can have ultimately we ended with ensemble forecast. That is the number of models you have. You can either do bagging, or you do stacking, or you do ensembling and all that. So that type of thing is there. So that's the these are the three: boosting, stacking, and bagging. So these are the three methods for assembly level. Okay. Shall we go to the next classification or wait for 5 minutes? Hello.
5 मिनट वेट कर लेते हैं सर.
Wait. Wait for 5 minutes.
हाँ, ब्रेक कर सकते हैं 10 मिनट.
Okay. Then it is 9:44. We'll start at 9:50.
ठीक है सर.
So, all of you are ready? Now
Yes,
we'll
sir. Yes, sir.
uh,
Yes, sir.
we start the classification unit 10. So basically, this is we'll study about the supervised, unsupervised, and all that we have done earlier also, and then we'll classification algorithm we'll study. We'll also study Dave Ways, K nearest neighbors, decision tree, logistic regression, super sport vector machines, and that's it. So so what exactly does learning entails? What exactly is meant by machine learning? So these are the things which are philosophical questions which have to be answered, which have to be understood very clearly. So gaining a solid understanding of how things work in practice. So that's where all the things that you just read it, you will find it. What is data mining? We have talked about data mining, a subset of business analytics that involves exploring an existing huge data set in order to discover previously unknown patterns. उसमें पैटर्न क्या होता है, जो डेटा है उसका पैटर्न क्या है, क्या कैसा बनता है, डज इट बिकम स्ट्रेट लाइन, डज इट बिकम इलिप्टिकल, डज इट बिकम पैराबोलिक, कैसे बनता है. So the field of artificial intelligence includes the subfield of machine learning. So data mining and machine learning, these parallel include the following. Both are considered to be analytical processes. Both are effective at recognizing pattern. Both focus on gaining knowledge. Both need a substantial quantity of information. So that's what it is. Following are some of the most important distinction between the two. Machine learning goes beyond what has happened in the past to make prediction about future events. Data mining, on the other hand, consists of just looking for pattern that already exists in the data. So machine does this plus prediction. So at the beginning of the process of data mining, the rules or pattern that will be used are unknown. In contrast, when it comes to machine learning, the computer is typically provided with some rules or variables to follow in order to comprehend the data and learn from it. The mining of data is more manual process that is dependent on the etc. The पढ़ लीजिए finding patterns and all these things and all that. So these are the for example, Euclidean distance, r2 minus r the whole square, this and all that. Manhattan distance is given by this. So this you can see that these are the some clear differences between the two thought. That is, one is uh, Euclidean distance, which is a square under root this, whereas this is a Manhattan distance, which is a t TI minus TJ उसका करके from h is equal to 1 to k. So that's where it's a under root जो स्क्वायर करके अंडर रूट लेते हैं इक्वलियन डिस्टेंस के लिए. कंप्यूटेशनल फाइनेंस, दिस इज द मशीन लर्निंग टेक्निक. ये हो गया अनसुपरवाइज, सुपरवाइज, क्लस्टरिंग. इसमें अनसुपरवाइज में क्लस्टरिंग करते हैं, इसमें क्लासिफिकेशन और रिग्रेशन करते हैं. सुपरवाइज में क्लासिफिकेशन और रिग्रेशन जो स्टैटिस्टिकल के, क्लस्टरिंग इज आल्सो स्टैटिस्टिकल थिंग. So understanding of supervised learning, so workflow, access and load the data, pre-process the data that we have done earlier. Work at a glance, go to the mobile. So this is exactly repeating what has been done earlier. Workflow at a glance. So this is a supervisor. Trading data set, desired output, algorithm, processing, and all these. Then you get the output. Is a three different outputs there. So this data is the input. Input raw data is here. So it breaks up into three different, because this is a red, blue, and red. There is two type of color, but it has been broken up into three this different. This. So that's the algorithm processing in this. Predicting heart attack with the help of supervised learning. Let's say doctor want to know if someone will have a heart attack in the next year. They have information about the age, weight, height, and blood pressure of the past patient. They know if the patient who were there before had heart attack within a year. So the problem is making this. Determine the type of training example, prepare, gather training data, determine the relation between the input features, select a learning algorithm, run the selected algorithm, evaluate the accuracy of this. Some of you can have a project on really having the heart attack on the various people and all that, and you can use the machine learning process of this process. You can just supervise learning. You can do that process very clearly. डिटेक्शन ऑफ स्पैम, डिटेक्शन ऑफ फ्रॉडेंट, जो फ्रॉड हो रहा है, बैंकिंग और अदर मेडिकल डायग्नोसिस, इमेज रिकग्निशन, predictive maintenance, and all these things. A very large number of practical applications of method can be outlined, but the following are some of the common. These are this. As I said, even election you can do, and all these things are there. Introduction to classification technique क्या होती है? Classification method makes prediction about specific outcome, such as whether an email is legitimate or spam. अब आपको ईमेल जो है आपके स्पाम में जाए या आपके इनबॉक्स में जाए, so that again is important classification required. So you have to again decide which email should go into the spam, which email should go to your inbox. Regression technique, the technique regression can accurately forecast continuous reaction, such as shift in temperature or variation in the amount of what power required. अब गर्मियों में कितनी पावर चाहिए है, आप अगर आपने फॉरेस्टेड एरिया में रहते हैं तो वहाँ कितनी चाहिए, जब open area में रहते हो कितना. All these things are well explained by machine learning processes, regression technique and all that. Then classification is the process of organizing data into predetermined number of categories. So structured data, unstructured data, classifiers, classification model, features, classification predictive model, binary classification. इसमें ज़्यादा आता है logistic regression, k nearest neighbors, decision trees, sport vector machine, naive basis. So more application areas are binary classification, detection of email spam, prediction of uh, prediction of churn. ये क्या है? Prediction of purchase and convenient buy or not. So multi class classification उसमें भी आ जाता है कि nearest neighbor, decision tree, naive Bayes, random for forest, and gradient boosting. So that type of thing, you can see that multi-level decision tree, multi-level random forest. So you know forests and trees. Forest is a big, each forest, each tree in the forest has a meaningful value. So that's where you have to see that in the forest, every tree is well taken care of it. Classification problem, this lazy learner will first store the trading data set, and then it will wait until it gives the test data set. Eager learner are trading data set to make a classification model before they get uh, other data set. So थोड़ा सा डेटा आया उस पर ही काम करना शुरू हो जाती है. दैट्स द ईगर लर्नर. लेजी लर्नर वेट करते हैं जब तक तब डेटा ना आ जाए. So you have to be a eager learner as this learner, but you have to be important. So therefore, you have to see decision tree, naive Bayes, and ANN are some examples of this. Whereas lazy learner का है KNN algorithm and case based. Your battery is running low. कैसे? Why battery is running low? ये ये नहीं है ऑन। नहीं नहीं, ये यही है। नहीं ये नहीं है। ओहो, तभी बैटरी लो कर रहा है। चलो, कोई बात नहीं है। व्हाट इज दैट, दे आर द स्टूडेंट्स, या? Oh, I had put my wrong plug into the thing. Sorry. Eager learner and lazy learner, we have studied and all that. Okay. So that's the example of eager learner include the classification technique of Bayesian classification, decision tree induction, rule-based classification, etc. And imagine on the other hand, in a lazy learner approach, the learner is required to wait until the final moment to develop a model for classification of the given test tuple. Or in a lazy approach, the learner just stores the training tuple given the for classification. It doesn't do generalization until it is given test tuples and so on and so forth. So this is a this. So classification algorithm, आप ये देखिए algorithm दिया हुआ है. This is the classification. The diagram that follows can be used to have a better understanding of classification method. There are two classes, class A and class B. Class A and class B, depicted in the graph that may be found below. These classes share characters, distinguish them from others. They are on the top of the line. This is under the line. So they are. That's what this is. The question arises as a result of the existence of variety of algorithms under both supervised and unsupervised learner. How should one choose which algorithm to employ? The task of selecting the approach and all that you can just go through this. Choose supervised learner, choose unsupervised learner. That's when you will to see this and all that. Where you use supervised learner, where you choose. So linear model, non-linear models, you can see that. So log cross this confusion matrix. Okay, this is a predicted classes, actual class, positive negative. This is true positive, false negative, so on so forth. You can see that. So that's where you can find out from there. So all this, the later AUC stands for under the curve, and the curve receive operating characters curve. So under the curve receive operating curve, and so you can see that there. Naive way हमने पहले भी करा था. This is an example of statistical classification which estimate the likelihood that a particular sample belongs to a particular group given the sample in the question. The Bayes theorem provides the foundation for it. When used in big database, the Bayesian classification demonstrates both improved accuracy and increased speed. In this section, we'll talk about most uh, basic kind of Bayesian algorithm. So this is the basic theorem. Bayesian theorem is there. Is in order to understand the theorem, first let's understand the meaning of following model or assumption there follows. X is an example of a data set whose class needs to be determined. H refers to the hypothesis which states that the data sample X falls into the class C. PHX, the probability that the data sample X belongs to the class C, is expressed by the formula PHX, where H is the hypothesis and X is the data example, so on. So you can just go through that. So that then comes PHX is equal to PX H by PH by this. So now, after defining the Bayes theorem, let's explain the Bayesian classification. So that's where you see, that is where you see, this is where it's a 1 to the j is greater than equal to I. Yeah, this is PCX upon PX. In our work, we are trying to classify this and all that. So this is the PC is the number of training samples and so on. So that 5 by 11, 6 by 11, so all these things. So ultimately, this is the result comes up there. So it is all the continuous going on. This is the result ultimately. Since the first probability of the above two is higher, the sample data may be classified onto the boss position. Kindly check to see that you obtain the same result from the decision tree. So Nave's Bayes stops to perform Naive Bayes algorithm. So step one, handling data. Step two, summarizing. Step three, making a prediction. Step four, making all the prediction. Step five, evaluate accuracy. And ti- step C, tying all together and with the help of the following example. Let's say we have a list of weather conditions and a target variable called play. So you want to say, will you play or do? Is it rainy? Play, yes. Sunny, yes. Overcast, yes. So on and so forth. And then you can say frequency table for weather condition is weather, no, yes. Overcast, 0, 5. Rain, 2, 2. Sunny, 2, 2, and 4. So total is 10. So there's total is 4 here. So no is 4, yes is 10. So that's where you can say that 14, 0 to 13, 14 values are there. So there are no are 4 and yes are uh, 10. So that's where, so no, 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 there are 4. No is 11th is no. Uh, this is sunny no, then this is sunny no. So that's it. This is rainy and sunny both no. So that's what is the weather condition and table to play this and all that. So again, likelihood table. So no, 4 by 14 because total number is 14. Yes is 10 by 14. So this is what is the forecast, rain, sunny. The weather is forecast is 0, 5, 5 by 14. Rain, 2, no. Yes, 2, 4. Then 3 to 5, 5 by 14. So that's the type of thing. This is 10 by 14. This is 4 by 14. So that's the all these examples are set there. High, low, this and all that. So that you can see that. So that 14 examples are there. K nearest neighbor. So you can see the K nearest neighbor. So we again talked about student distance, Manhattan distance, and all that. That see the same thing you calculate and all that. Then K defined again gender, height. Male के height ज़्यादा है, female की कम है. That's what you see that. So from there you can say Sunita, Julie, Shelley, and this Pooja. This is female, male, female. So height, class, short, short, and medium. So that type of thing which is there. So that male 1.7 because male 1.7 meter is short. Female 1.6 meter is short. Puja is female 1.75 meter is a medium. So on examination the topic tuple above we classify the tuple less than Ram M 1.6 greater than to short class since most of the tuples above belong to short class. So 1.6, 1.7 and all that. 1.75 is only medium this and all that. So Similarly, examples is there and all that. You can see that. Check your program. Say there's the example decision tree. So this is the each internal node is labeled with the attribute A. Each arc is labeled with the predicate which can be applied in the attribute at the parent node. Each leaf node is labeled with the class C, and that's where it goes on algorithm for classification. It's a software is there. Then it's a low range, medium range, boss, this is this, all, all the things are there. Age, assistant, boss. If his age is less than 30, he is assistant. He is more than 40, he is a boss. सैलरी 31 to 40 की सैलरी ये है असिस्टेंट है बॉस है सो ऑन सो फॉर मीडियम रेंज डिपार्टमेंट एडमिनिस्ट्रेशन assistant boss person and all that. So that's where it's the decision tree using id3 algorithm for sample data. So that is 21 to 50 का बनाया हुआ है. So high range salary, high range is boss, low range is assistant, again medium range department person is boss, administration assistant or boss. So that type of thing which is there. So this is a normal, weak, strong and all that, humidity, rain and all that. So that type of thing is there. So this is again sunny, hot, humidity, this great, weak and all these things are mentioned there. Outlook is sunny, overcast, rain. So yes, so that's what. If is it sunny, is it overcast, or is it raining? So that type of thing. You hear humidity high, wind strong, played, played yes or no, and so on and so forth. So these are the examples given and all that. Outlook, humidity, overcast yes, wind strong, एंड वीक. तो वीक में खेला जा सकता है, स्ट्रांग में नहीं खेला जा सकता. तो ओवरकास्ट में खेला जा सकता है, लेकिन नॉर्मल में खेला जा सकता है, हाई में खेला नहीं जा सकता. ह्यूमिडिटी हाई में बहुत बुरी हालत होती है. सो लॉजिस्टिक रिग्रेशन. सो दिस इज रिग्रेशन. ओके, द इक्वेशन इज कवर्ड लाइक दिस. योर mean statistic regression. Sport vector machine, that's important. That's a new thing which you should know that. Sport vector machine, also called sport vector classification, is supervised and linear machine learning technique that is most often used to solve classification problem. In this section, we'll take a look at sport vector machine. So SVM is while studying the machine learning, one of the classifiers that we come across is called a sport vector machine. One of the most common approaches for categorizing data in the field of machine learning, which perform admirably on both small and large data sets. SVM, which stands for sport vector machine, can be utilized for both classification and regression jobs. However, their performance is superior when applied to classification scenario. When they were first introduced in 1990, they quickly became quite popular, and even now, with only minor adjustment, their solution of of when high performing. So this is showing data in two groups. ये देखो, ये ऐसे डेटा है, इधर ये डेटा है, इधर ये डेटा है. इसमें ये डेटा है, ये देखो एक लाइन है, दो लाइन है. इसमें भी देखो एक लाइन, एक डॉटेड लाइन, दो डॉटेड लाइन. So this is the data which comes up here. This is the data which comes up here. This is the data which comes up here. This is data which comes up here. So that's why showing data into two groups. These are two main categories: linear sport vector machine, non-linear sport vector machine. You can only use linear sport vector machine if the data are completely separated into linear category. Non-linear machine when the data isn't linearly separable, but we can use non-linear. So this is the, for example, this is non-linear, this is linear. So sport vector, the points on the hyperline, they are in closest in the object in question, are referred as sport vectors. The boundary between the two groups will be determined with the help of these data points. In fact, these are the inputs on the hyperline that are closer to it. These data points will be used to define the separation line. Margin, the margin is the distance between the hyperplane and the nearest observation to this. So that type of thing. So diagram of a sport vector machine. So this is the again ये मेन लाइन, ये दोनों डॉटेड लाइन, ये एक डेटा हो गया, ये दूसरा डेटा हो गया. दिस इज द हाइपर लाइन, this is a negative hyperline, this is a positive hyperline, and that is the maximum margin, and this is the maximum margin hyperkit. So this is the, that this is the maximum margin and all that, and this is the sport vector machine. Working of sport vector machine is defined solely in terms of sport vectors. We do not need to be concerned with any other observation because the margin is calculated based on the points and all that. So this is the, to further understand how so operates. Let's look at an example. Suppose we have data set that has two different classes. These are the two different classes. They are many ways to put these two puts into this. There, this can be put like this can be put like this can be put like this. So these are the hyperplanes. This is there. So one data set covers up here, other data set covers up here. So either you can have use this, or use this, or use this. So these are the different ways of doing it. So this is another way: optimal hyperplane, sport vector, and sport vector. So that's the type of thing. So this is sport vector, this is sport vector. Check your progress, solution answer. So that covers up this. So sport vector machine is quite often asked, used in the machine learning, so that you should look up the various various ways of doing it, so that you can see this one. You can see starting from this, you can see this diagram, then this diagram, this diagram, this diagram, and lastly, see this analysis of this here. So that covers up the second unit. You can see their various examples are there. Now, next unit is regression. Uh, we can do this third unit: regression, introduction, regression algorithm, linear regression, polynomial regression, sport vector regression. So this is, you can say, height child is this simple regression, it is height x is equal to y minus this and all that. So this is the height child is this constant plus this into height of the parent, depending upon, because the parent's height has a genetic value, so therefore child height will depend upon the parent's height. So that's where it's a parent child, parent child, parent child. So this is the height of the child is 21.52 plus 0.69 into height of the parents. So usko general value, this is a simple regression equation. This is a slope prediction. Regression equation से prediction होता है. You can see all the type prediction is done by regression equation. Regression, linear regression, ये आपने देखा child का height and all that. Multiple linear regression में y is equal to a plus bx plus cx to cx, इसमें ज़्यादा वेरिएबल आ जाते हैं. Okay, x1, x2, x3, and all that. So that becomes non-linear, multiple linear regression. Logistic regression is a logistic regression algorithm depends variable in binary in nature, false, true वगैरह देखे देखे false and true से देखे. Polynomial regression is a polynomial regression is described with the help of a polynomial equation whose the occurrence independent variables is more than one. Ecological regression is used when group data belongs to a group. Thus, data is divided into different groups and regression is performed on different groups. Ecological regression is mostly used in political research, for example, party, boards, election, and all that. Ridge regression, it is a type of regularization when data variables are highly correlated. Ridge regression is used. Using some constraint on regression coefficient, it is used to reduce the error and lower the bias. Lasso regression is the last absolute thinking, shrinking, and selection operators regression. So this is the logic regression, Bayesian regression, quantile regression, and Cox, Cox regression. Cox regression algorithm is used when uh, we'll study this linear regression. तो आप देख लिया है. This is the linear regression. These are linear regressions. Independent variables, speed is. These are linear regressions. So area flat. This you can see this. These are the examples which are there. True or false. Next comes polynomial regression. So this is a polynomial because this is a not a straight line. It's a polynomial regression. It's a parabolic or this one is there. So this one is also this is more or less straight line, but if you go detail into it, that may also becomes more curve like this. But this is a definitely non-regression, non-linear regression. So ये देखिए A2 B1 X1 B2 X2 B3. So this is what the simple way is. So the A0 plus B1 X1 I is equal to 1 to n. So that becomes the regression equation. You have to follow this. So this is the from the given data point. This you have to have the regression build up. Sport vector regression. वो आपने देखा है कैसे स्पोर्ट का हाइपर प्लेन बनाते हैं. ये डेटा है and data is here. So and then these are the two dotted lines. This is the main line. So that's what is the so called sport vectors. ये स्पोर्ट वेक्टर ये देखिए थ्री डायमेंशन हो जाता है. ये ऐसे बना देते हैं. इसको इस डेटा को ऐसे कर लिया है और ऐसे कर सकते हैं. सो स्पोर्ट वेक्टर से so it's always main and dotted things and all that, so that this is three dimensional on that plane ऐसे लगाया हुआ है, whereas this is also three dimension. ये सारा उसका application of sport vector regression. So ये दिया हुआ है. So that covers up the third unit. So that's all. We will do fourth unit and continue with the other. We'll also do uh, Sophia. Next class, we'll show you how the Sophia has been built up and all that. And Sophia knows 20 languages. Sophia can talk, can express, can dance, can sing, can this and all that. So that we'll do in the on 24th. Uh, 24th we'll do that. We'll do the fourth unit and also this. And on 25th we'll do all the rest of the four units of the block 4. Okay? Any question on this? आप
Okay, sir.
इसको पढ़ लीजिए जरा. You will see that all these examples, when you go through this, you will find it interesting. अगर कोई problem होती है, then you will discuss it. So
Okay, sir.
आप अभी rest कर लीजिए. We come back by 11 o'clock,
Okay, sir.
so that we have the big data class also at 11 o'clock. Okay?
Okay, sir.
Thank you, sir.
Okay, sir.
अभी attendance अभी एक मिनट अभी जाइए मत. मैं अटेंडेंस ले लूं जरा. ओके, लेट मी टेक द अटेंडेंस प्लीज.
हाँ सर ले लो.